Hello, lovely students and lovely identities. Yadona. You must all know that this is very lovely and it's too much fun, better than anything in life. So these questions are also from the Precalculus book, and it's saying rewrite as an expression that does not include a fraction. So it's kind of conjugates. It can be simplified by conjugates. If you remember what does conjugates mean, it means the same as this, but the opposite sign. So I multiply it by, somehow I can see the Pythagorean identity, this one. But first of all, I'm going to multiply by the conjugate of this. So I have cosec x plus cotan x. Why am I doing that? Because this will help me reach the Pythagorean identity that I just showed you, this one, somehow, and then I will end up with having a no fraction. Your final answer should have no fraction. Okay, so if I multiply the numerator, I'm gonna get sine x cosec x plus sine x cotan x. صح? All over what? First with first, last with last, I'm gonna get cosec squared x minus cotan squared x, which is very helpful for me because cosec squared x minus cotan squared x is 1. Okay, watch out if the question was asking, or you reached a cotan squared x minus cosec squared x, it was going to equal to -1. We can get a lot of equivalent identities to this one. But now I have cosec minus cotan, so it's equal to 1. So actually this is 1. And here I can see reciprocal functions multiplied by each other. So here I have sine x times 1 over sine x. Just to clarify to you that this will end up in 1 plus sine x times what I'm thinking, and this is cosine x over sine x. And you have to train yourself to think this way. Can I do something? Yeah, I can do, because this is cosine over sine. So what did I end up with? This one, it's not 0, it's still 1 there, plus cosine x. And here I'm done with the fractions, and this is the target of these questions. Okay. Why am I solving so many questions? Because you need to practice so many questions to start getting adapted to these, or to make it easier for you. So you must solve as much as you can with me, and you must solve as much as you can from the homework. Regarding question 39, I'm not being muftariya, but this chapter really needs to put effort, needs you to put effort, and inshallah you will have all these videos for you as a reference in case you wanted to review in summer, you wanted to review in grade 12, because this is a very important chapter in grade 12. Okay, so over here what will I do? I'll multiply by conjugates. I'm gonna get 1 plus sine x over 1 plus sine x. Okay, as a start. So what am I getting? I'm getting cosec, I'm always forgetting one of the c's, cosec x plus cosec x sine x, and the denominator will be 1 minus sine squared x. 1 minus sine squared x is this one. 1 minus sine squared x is cosine squared x. Mazboot. These are reciprocals. Okay, so they will cancel each other. So I'm gonna end up in cosec x. Okay, I'm gonna write it all in case you're not getting me, times 1 over cosec x. Okay, so this will cancel this. So, and here this is cosine squared x according to Pythagorean identity. So this is cosine squared x. The final answer, I don't want a fraction. I don't want a fraction in these questions. Usually we don't want we don't want trigonometric functions in the denominator. So the final answer, I'm gonna take this up, so it will be sec squared x multiplied by cosec x plus 1. Khalas? Once you're done with the fraction, no fraction, this is the answer. How did I get this? Because I took the cosine squared x up, because cosine squared x, 1 over cosine squared x is sec squared x, and if it's cubed, it's like cubed x, and it's to the power 4 to the power of 4x. Here I'm done with question number 39. Question number 40. Again, what will I do? I am seeing this one. It's x squared x minus tan squared x. But how will I get that? I will only get it if I multiply by, I will only get this one if I multiply by conjugate of this. So the target of the conjugate is to reach difference of squares or to reach these Pythagorean identities. So if I multiply by sec x plus tan x all over sec x plus tan x, what will happen? The numerator, if I start distributing directly to cut it short, I'm gonna get cotan x sec x plus cotan x tan x. These are 1 because they are reciprocals. All over this by this is sec squared x minus tan squared x, and sec squared x minus tan squared x is equal to 1. I'm done. Just a little bit of more of simplifying, because I can see I can simplify in the numerator. This cancels this and it's gonna end up in 1 because they are reciprocals. And for the cotan, I can change it to cosine x over sine x times the sec is 1 over cosine x plus 1, this one, and here this cancels this. So your final answer in simplest form is cosec x plus 1. You can pause and try with this one. Again, if I multiply it by 1 minus sine x over 1 minus sine x, this would give me cotan x minus cotan x sine x all over 1 minus sine squared x. And what's 1 minus sine squared x? Cosine squared x. Sa? Cosine squared x. So I ended up in a cotan x minus cotan x sine x all over cosine squared x. Mazboot? Okay, I can split here this over this and this over that because I have one denominator only. I can do that, okay? So I can change the question to cotan x over cosine squared x minus cotan x sine x all over cosine squared x. There's no problem in doing that, okay? So now cotan x is what? Cosine over sine. So I have cosine x over sine x all over cosine squared x minus, here cotan is also cosine x over sine x times sine x all over cosine squared x. In this case, this can cancel this. Mazboot. And here, one of those can go with one of these. I can take the sine x down to make it more clear for you. So I can have cosine x over sine x cosine squared x minus, here now I have cosine x over cosine squared x. Now I'm just trying to clarify that this can go with one of those and this can go with one of those. What am I left with here? 1 over sine x cosine x, 1 over sine x times cosine x, mazboot, minus 1 over cosine x, there's no space, 1 over cosine x, mazboot, mazboot. So what will I do now? If I take a cosine x as a common factor from these two, or if I take 1 over cosine x as a common factor, let's say 1 over cosine x as a common factor, what will be left here? I'll be left with 1 over sine x minus 1, صح? minus 0, minus 1. If I distribute, 1 over cosine x sine x or minus 1 over cosine x. So 1 over cosine x is what? Sec x. And 1 over sine x is cosec x minus 1. And this is the answer without any fractions. This one took too much. No, sorry. Somehow this is the way of doing it. Okay. For regarding question number 42, I think I need more space for that. So for question 42, I'm gonna get another paper maybe, and here I will just write the final answer. For question number 42, the question is 3 tan x all over 1 minus cosine x. طيب, what will I do? I would definitely start by multiplying by 1 plus cosine x, and here I will have a Pythagorean identity in the denominator. So 3 tan x, I'm distributing the numerator, plus 3 tan x, let me keep it for now, okay? 1 plus cosine x all over what? 1 minus cosine squared x, and خلاص, we know that 1 minus cosine squared x is sine squared x. Okay, let me change this tan x into okay, let me go on. This is 3 sine x over cosine x times 1 plus cosine x مظبوط all over sine squared x. This is this. صح? Okay, I've tried to change the question somehow into just to make it clear for you, into 3 sine x over cosine x. You can have other ways, times 1 over sine squared x. Isn't it the same? It's the same as 3 sine x cosine x over sine squared x. Okay, or multiplied by 1 over sine squared x, all times 1 plus cosine x. As long as it's a multiplication and division, there is no problem. I just want to clarify that I want to cancel this with this. Okay, so now I have 3 over cosine x sine x, okay, times 1 plus cosine x. Okay, let's distribute now. Maybe you can distribute from the beginning and reach the same answer. You can try. You have all the options. Sine x plus 3 cosine x. Sometimes, as I told you, I suffer to find the simplest way to do that. Anyways, but then I will reach. I will not sleep until I reach. So over here, I can take these as their reciprocal functions, which is sec x, cosec x, because this is the answer. Plus, I'll take the sign up. It will be 3 sec x, cosec x. صح? Cosec x. So I can see a cosec and a cosec and a 3 and a 3, and the final answer in the book is 3 sec x times sec x plus 1, and this is the answer. Okay, that's it for this part. I hope you did understand how to write the trigonometric functions without involving any fractions, or the trigonometric identities without, they're not identities actually, they're just functions, without I will tell you what to do with the homework. Okay.